But sir, how will I use this in real life? Well, that's the question we're going to answer today. We're going to be doing some applications of solving polynomial equations. And yes, I know that if you're going into writing or art or business, you're never going to solve polynomial equations. I get it. But this is making you smarter, I promise. It is making you more intelligent. And for those of you that are in math and science, well, you will be using polynomial equations a lot. They kind of just keep showing up all over the place. That's why we learn it in Algebra 1, because it's a big deal. So the essential question today, I learned how to solve polynomial equations. How can I use my knowledge to solve real-world problems? So let's take a look at the first real-world problem, and I'll switch to perhaps a more palatable color. Maybe we'll try blue today. Okay, that looks lovely. So you're designing a flag. Here's the flag. And you're designing a flag for your school football team with the following dimensions. The flag requires 117 square inches of material. Find W. Okay, so first of all, we have this flag. I guess I want a red section to be over here. Maybe I want to put the letters of our school. And I can know for sure that 2 is the width of this here part. And I know that the width is this. So I definitely know for sure kind of what I want this part to be. But then there's this other part where, yeah, I want the length to be W plus 2, and I want the width to be W. So these are the dimensions of my flag. And I know that I want the area of my flag to be 117. Now, how do I know the area is 117? Well, look at the units. If I have square inches always refers to area. So I know for sure that I want the area to be 117. So, just like we found the area earlier on a previous quiz by kind of looking at the two rectangles and subtracting them, let's take a look at the two rectangles I have here. We'll add up their areas and they should equal 117. So this area is going to be, well, length of 2, width of W, 2W, length times width. Now let's do the area of this square. It is a length of W plus 2 and a width of W. W plus 2 times W. This is distribution, so W squared plus 2W. That's the area of that rectangle. And I know that when I add up these two areas, so when I go W squared plus 2W, this area, plus 2W, this area, that should be equal to the total area of the flag, 117. Okay, cool. So yeah, let's combine some like terms. We know that this is a polynomial equation, and so the first step is to get a 0. So W squared, we'll combine the like terms. We will get our 0 by subtracting 117 from each side. That looks like 177. It's not. And I know that my second step, I need to factor, so then I can make use of, finally, the zero product property. So first, I'm going to factor. Now here's the issue. I don't really know multiples of negative 117. Like, this is a reverse FOIL problem. I should definitely be looking for multiples of 117 that add up to 4. But multiples of 117, I don't really have them off the top of my head. And so here's a useful technique. If you have a really big number whose multiples you don't know, instead of trying to list multiples of that number and then figure out which ones add to 4, what if we found numbers that add to 4 and we see if they multiply to 117? So kind of thinking about it backwards. Now I know since I'm eventually going to be multiplying to 117 and it's negative, I know that in my parentheses I'm going to need to have one positive and one negative. And so it'll be kind of like subtracting. So in other words, let's test some numbers that subtract to 4 and find out if they multiply to 117. So for example, 20 and negative 16. These subtract to 4. What happens if I multiply them? So we can pull out our calculator. This, when I multiply them, is negative 320. Way too big. Okay? So let's go way smaller. How about 15 and negative 11? 15 times negative 11. This ends up being negative 165. Still quite a bit too big. Let's try 13 and negative 9. And sure enough, this does multiply 17. So my winning combination is 13 and negative 9. Those add to 4 and multiply to negative 117. So now I can make use of the zero product property. Remember, I'm saying, hey, If this parenthesis is equal to 0, I have a solution. So subtracting 13 from each side would give me a solution. Also, though, if this parenthesis were equal to 0 and I added 9 to both sides, this would also give me a solution. So W could either equal negative 13 inches or 9 inches. I think one of these solutions doesn't make sense, though. Let's think about it. What would it even look like to have negative 13 as my width? Like, would the flag be like folded in on itself, like some weird alternate universe? So even though this makes sense mathematically, this solution does not make sense in a real world context. So let's just stick with the 9 inches. Because it's positive, it does make sense in a real world context. Okay, example 2. We have the area of a triangle. It's 234 square feet. I had tried to do this problem with 702 square feet and totally messed up. So this is actually my second go through recording the video because of the faux pas of having the wrong numbers. Anyway, we need to find the value of x. Now, here's my triangle. I know that the height is x. I know that the base is x plus 20. What's the area of a triangle again, though? So the area of a triangle is equal to 1/2 base times height. So let's plug in some different things that I know. I know that the area is 234. I have 1/2. I know that the base is x plus 20. Make sure to put it in parentheses. I know that the height is x. Okay, so now I have an equation and I can solve it. Now, this 1/2, this is going to cause me nightmares if I try to distribute it in because we haven't learned good techniques of factoring when we have fractions involved. So, remember back to the very beginning of the year, we had some techniques for how to deal with fractions, and the technique was, hey, if I just multiply both sides by the reciprocal right away, it will cancel. I'll be left with x plus 20 times x on the right-hand side, and that's awesome because now I don't have a fraction. 2 times 230 is 468. Now I still need to distribute, and as we can see, an x squared shows up, which means yes, it is a polynomial problem. So I need a 0 on this side, so let's subtract 468. Nice. So now I'm trying to factor, and here again, I don't know multiples of 468. So let's think. I have x and x. I know that to multiply to a negative number, I'm going to need a plus and a minus. So instead of thinking of numbers that multiply to 468, let's think of numbers that subtract to 20. Let's try 24 and negative 4 and see what this multiplies to. So 24 times 4 multiplies to negative 96. This is not big enough. So let's try 26 and negative 6. This is negative 156. This is also not big enough. Let's try 28 and negative 8. 28 times negative 8. Okay, still not big enough. I need to up it a lot. This was only 224. I'm not guessing intelligently. Let's try maybe 38 and negative 18. 38 times negative 18. That's way too big, negative 684. So maybe somewhere right in the middle. How about 34 and 14? Let's try this. 476. And I think, unfortunately, I have another problem that isn't going to work out properly. And this is really, really frustrating because I got this out of the book and nothing seems to be working out. And I'm banging my head against the table right now. Did you hear the sound effect? That's me banging my head against the table. Okay, so here's what I'm going to do. And this is totally cheating. I'm going to change this 234. You're not allowed to do this on a test, but on a test I will have tested this problem beforehand. We're going to change this 234 to, I don't know, let's do 238. So now the area is 238. I may have just read it wrong out of the textbook. So now when I multiply by 2, I'm going to get 476. Oh, hey, how convenient, 476. Okay, and here's the winning solution. Yay, x plus 34. X minus 14. That means x is going to equal negative 34 or x is going to equal 14 when I use the zero product property. Are you allowed to do that on a test? Just change the original starting problems? No, but I'm allowed to do so because I'm the teacher and I get to make problems how I want and I get to make them so that they work out nicely. Now here again, it does not make sense to have a negative x. Why? Because it doesn't make sense to have a negative height of a triangle. What's a negative height? Like it's going down into the ground? What is this nonsense? This is the only one that makes sense. Let's just make sure to include units, which I think in this case are feet. Wow, what a fun video. I totally butchered that second problem. My bad. Anyway, summary, don't forget that when you're solving these polynomial equations, get a zero, then factor, then zero product property. We learned some techniques. For example, if you have a half, you can get rid of it by multiplying through by 2. That's nice. And don't forget that if we have really big numbers that I don't know multiples of, we can try to instead start by adding to the middle number and see which ones multiplies to that last number. Hey, thanks for watching. Maybe I'll get the problem right next time.